take some different type of the test, and along with the reports, the patient has to enter into the consultation room second time also. Okay, that is second response. Okay, that is the meaning of first response, second response. Now, so this is the concept of CPU scheduling. We have different types of the CPU scheduling algorithms. These are very frequently used or popular CPU scheduling algorithms. CPU scheduling means how the processes are scheduled to execution. That concept is called CPU scheduling because we have only one CPU in our system in general. More processes are waiting for the execution. The how the operating system is picking that process for the execution. So that process is called CPU scheduling. Now, first category of algorithms is first come, first serve, FCFS. You may get the question like, explain about FCFS. You must remember the name. First come, first serve algorithm. First come, first serve CPU scheduling algorithm. Then shortest job first, priority scheduling, round robin scheduling. These are very popular CPU scheduling algorithms. Now we'll discuss these one by one. First come, first serve. By the name, you can understand that. First come, first serve. Assume that there is a shop and 10 members are waiting in front of the shop to purchase the products. Assume that there is a supermarket or normal shop, whatever. 10 members are waiting, or all the 10 members are in the queue. They are maintaining some queue. And how the shopkeeper wants to deliver the products, the way is who come first to the shop and the shopkeeper deliver the products to that person first. First come, first serve. First number person delivered to the first. Who arrives second and the products will be delivered second. Sequential order. How they came to the shop, in the same order, the shopkeeper deliver the products to those persons. In the same way, as we covered already, so many queues are there in the primary memory in our computer system. So many processes are waiting for the CPU time for the execution. Now, this algorithm describes that if we implement this algorithm, if processes, if CPU is following this algorithm, the way of the execution is first came process. The process which came first into the ready queue, that will be executed first. The process which stores in the primary memory second, that will be executed second, and so on. So very simple. First come, first serve. The order is serial order. In which order they arrived into the queue, in the same order, the execution will be done. So this is about first come, first serve CPU scheduling algorithm. See, in the FCFS, CPU allots the resources to the process in a certain order. The order is serial order. The CPU is allotted to the process in which it has occurred. The meaning is in which order they stored in the main memory. In the same order they used to execute the processes. We can also say that first come, first serve CPU scheduling algorithm follows first in, first out in ready queue. The meaning of the word first in, first out means who in first time, that person should be the first out. Just like a queue. You may observe the different queues now. Suppose you want to take the ticket in the railway station, offline mode. We maintain some queue. Who stand in the queue first, they may take the ticket first. First in, first out. Who come first, they will go first. So that is the meaning of first in, first out in ready queue. So in the ready queue also, same queue is maintained. First in process will be executed first. Now, what are the advantage and disadvantages we have in FCFS? The advantages are very easy to perform by the CPU because very simple algorithm it is. Depending on the sequential order, the process will be executed. That's it. Then follows FIFOQ approach, nothing but first in, first out. Which come first, that will be executed first. Simple approach. Then disadvantages, FCFS is not very efficient because assume that there is a queue in front of the medical shop. 10 members are there. Assume that we are implementing FCFS. So who came first? The medicine will be delivered to that person first, and second person will get the medicine second time, and same order. But here, assume that the ninth person who stand in the queue at the ninth position, that person wants to take the medicine very urgent. That might be any serious situation. But if you following FCFS, that person has to wait. So this is the problem with FCFS. We are not considering the importance. Just simply we are following order. So sometimes that may not give the good results. So that is a disadvantage. This problem is called convoy effect. Convoy effect. Convoy effect means the person, suppose in the 10th position, there is a person and they wants to take only single product. But the persons who stand before the 10th person, they are taking hundreds of products, tens plus of the products and so on. Even though the work is very small work about the 10th person, because they want to take only one product, like only one soap, let us say. But the 9 people who are standing before the 10th persons, they are taking 10 plus products, hundreds products. Even though the time taken to deliver a single product to the person who's standing in the 10th position is very small amount of the time. But still, that person has to wait because the algorithm we are implementing is FCFS. As per the rules of the FCFS, that person has to wait. In the same way, assume that we have 10 processes P1 to P10, process 1, process 10. P1, P2, P3, and so on, P9 takes 10 seconds time to execute, let us say. But P10 takes only 1 second of the time to execute. Very small process. But even though that has to wait until the completion of P9, P1, P2, P3, P9. After completion of execution of P1 to P9, then only P10 entered into the execution stage. So this is called convoy effect. P10 has to wait for a long period of the time. This is convoy effect. Now, see the example. So you may not get this type of the in-depth question. You may get the question like, what is FCFS? What are the advantages or disadvantages? And explain about that. You may get the questions like that. But anyway, let me give some overall idea about this Gantt chart. So this is called Gantt chart. Observe here. And you will get the question like this. If time permits, or if sometimes only, you may not get like this. But if any case, if you get the question, I will tell you how to answer. You will get the question like they give some process names. You will get this timetable, this table also as part of the question. They give some algorithm names. The question formed like this: by using the first come first serve algorithm, calculate the execution time of the processes or total time taken by the processes. Like that, you may get the question. They may give this table also as part of the question. Okay, then how to solve that? See, this is also part of the question as I said. Process ID, nothing but we have 5 processes in the memory. Those processes can be identified with help of the IDs like P1, P2, P3, P4, P5. 5 processes. Arrival time means at what time the processes entered into the primary memory. Okay. Assume that the time second unit of time 5, 0, 0, very starting point. They entered into the ready queue and 7 unit of the time. Bust time. Bust time means how many, in simple terms, how many seconds required to execute this P1. 6 seconds are required to execute P2, like that. Okay. Bus time is a time taken by the CPU to execute particular process. Now, depending on that, you need to write complete Gantt chart now. See, Gantt chart is, you must take this diagram like this. Don't fill anything first. Initially, you must write 0. Just forget about all these things. Initially, you must start 0 because the times starting point of the time is 0. We are assuming that 0. And now, just focus on this arrival time. Focus on the arrival time. Which process arrived first? Okay. Just like assume that this is 2 a.m., 5 a.m., 0 a.m. and 7th a.m. If you compare this with the time, 0 is the first one. Okay, it comes first. So you can start the preparation of this Gantt chart either with P3 or either with P3 or P4. Two are valid because those two processes arrival at 0 time. Now here I am starting with P3. Just write P3 here first. Then how much time required for the P3? 4. And close the P3, write 4 here. Okay. Nothing but 4 seconds, in simple terms, 4 seconds are required to execute P3 like that. Okay. Now I start P4 because observe this ascending order 0 and 0 P4. To execute P4, the CPU required 7 seconds. Assume the units is second. Actually, that is not in seconds, but to make the concept clear, I'm using the word seconds. 7. So you must use plus 7 to the previous value. For the P4, the CPU required 7 seconds. But already 4 seconds is taken by the P3. 7 plus 4, 11. Nothing but at the 11th seconds, the P4 will be execution of the P4 will be completed. The meaning of this is at the 11th second, whenever the time is reached to the point 11th second, at that moment, the execution of the P4 will be completed because first 4 seconds for P3, next 7 seconds for the P4. Totally 7 plus 4, 11. So this is accumulated value. We are adding the value for the previous value also. Next, 0, 0 is completed now. Next 2. P1 comes for the execution. P1. Burst time 2. Already 11 we have now. Cumulated time 11 plus 2, 13. You can write 13. The meaning is that at the 13th seconds, 3 process execution will be completed up to 13th second. Then 0, 0, 2 is completed. Next 5. P2. Write P2 here. 5 seconds. Already the previous value is 13. 13 plus 5, 18. Actually, this is 18. It's wrong. We should make it as 18 only.
సార్ అక్కడ 5 ఎట్లా ఎందుకు వస్తుంది సార్? 6 వస్తుంది కదా అండి. 13 to 19 అంటే కౌంట్ చేస్తే 6 వస్తుంది సార్.
Yeah, you can use 5 here, change it as 18. Otherwise, if you want to maintain 19, you can change it as 6. Yeah, okay, you're right.
Okay.
So bus time, so 13 plus 6 bus time, 19. Yeah, good. Next. So after that, we have only one P5 and come to the P5. Arrival time is 7 and 19 plus 4 bus time. Okay, 19 plus 4, 23. So this is how to create Gantt chart. Clear, I hope?
సార్ P3 అరైవల్ టైం 0 ఇట్స్ ఓకే సార్. బట్ P4 కి కూడా అరైవల్ టైం 0 ఎట్లా సార్?
Yeah. So here the thing is P3, P4 రెండు కూడా మెమొరీలోకి ఒకేసారి వచ్చాయని అనుకోండి మనం ఈ ఇన్పుట్ వచ్చింది అంతే.
ఓకే.
దిస్ ఈస్ పార్ట్ ఆఫ్ క్వశ్చన్.
ఓకే సార్.
ఓకే. సో రెండు వచ్చినప్పుడు ఏం చేయాలంటే మనం ఈ ఏ ఆర్డర్లో అయితే క్వశ్చన్ ఉందో అందులో ఫస్ట్ ఉన్నది తీసుకోవాలి. ఓకే, రైట్. నౌ సో ఇప్పటివరకు ఈ టేబుల్ ఇంకా కంటిన్యూ చేయాలంటే ప్రాసెస్ ఐడి, అరైవల్ టైం, బస్ టైం, and we calculated CT. Okay. Then after that, total around time. CT means completion time, total around time, and waiting time. So we can calculate each and everything with help of the formulas. Average waiting time, turnaround time. Double T means RT waiting time. So if it is a non-preemptive algorithm, preemptive and non-preemptive algorithm we covered. Preemptive means part execution. Only 2 units of the time will be executed for a particular process, and next 2 seconds for the P2, next 2 seconds for the P3, and so on. But actually, FCFS is not a preemptive, continuous execution. Once, if we observe that, once the execution is started, the complete time will be allotted for the P4 only. Suppose P3 bus time is 4 seconds. Once P3 is allocated for the CPU, the execution completed. 4 seconds completely given for the P3 only. This is non-preemptive. Preemptive means only 2 seconds might be, and remaining part will be executed later on. Just like a web series, episode by episode. Execution also same thing, part by part. Okay, that is preemptive. Now, next one is shortest job first scheduling algorithm. And by the name also you can understand the concept shortest job first. Shortest means the process which takes very less time to execute. Technically, which process has very less burst time? Which process has very less burst time? That process will be executed first. That is the condition we implemented in the shortest job first scheduling algorithm. See now, so as of now, we are scheduling the process according to the arrival time, that is FCFS, first come first serve. And coming to the SGF, that is shortest job first algorithm, this process follow according to their burst time. FCFS according to their arrival time. Shortest job first algorithm is developed based on their burst time. So in SGF scheduling, the process with the lowest burst time, the process which has the lowest burst time among the all other processes in the ready queue, that will be selected for the execution. Otherwise, that is going to be scheduled for the execution. Then, however, it is very difficult to predict the burst time needed for a process. Hence, this algorithm is very difficult to implement in the system. The meaning is, so, of course, we are discussing this theoretically, but coming to the practically, we cannot say that this is the accurate number, accurate bus time, because there are so many factors those affect the execution of your particular system. Might be hardware problems, might be less amount of the RAM, or any software issues. So many things are there which affect the speed of the execution of a particular system. That's why in real time, practically, somewhat difficult to say complete a certain number of the bus time. But we are discussing some theoretical concept, but theoretically we are using some bus time. Practically, we may not give certain number. That is not possible in practice. Now, advantage and disadvantage of the SGF. Maximum throughput. As we covered, throughput means number of the processes executed by the CPU per unit time. Now, if we follow shortest job first, the CPU can execute more processes per unit of the time. For example, in the FCFS, if we implement FCFS, the CPU can execute 5 processes for 1 minute, let us say. But if we implement for the same processes, shortest job first, that can execute 6 or 7 processes. Because, as I said already in our example, even though one person is in the 10th position, they wants to take only single product. Now, what we need to do? We need to pick the person who wants to take less number of the products first. In the shopping example, 10% are there, but the 10th position person wants to take only single product. So we can give the single product, and we can vacate that person from the queue. So same concept we are implementing in the shortest job first. So obviously the queue will be emptied as soon as possible, because we are trying to remove the persons from the queue, because we are giving only one product. The 10th position person may went out from the queue. One process is executed already, like that. Now, it is probably optimal in that gives the minimum average waiting time for a given set of the processes. Obviously, in the FCFS, as we are following first come first serve, even though the last person wants to single product, they need to wait for a long period of the time. Waiting period is very heavy time, very long period of time they need to wait. But in the shortest job first, the shortest job will be called first for the execution. So remaining process, no need to wait for a long period of the time. So this is also one of the advantage. Coming to the disadvantages, SJF may cause starvation if the shorter processes keep coming. The meaning is, assume that same shop example, and the 10 members queue is there. First person wants to purchase 10 products, let us say. Before the shop, there is a queue. In that, the 10 persons are waiting to purchase the products. In that, first position person wants to purchase 10 products. Assume that second position person wants to purchase only one product, and the third position person wants to purchase two products, and the fourth position person wants to purchase four products, and so on, less than 10 finally. But what happened there? Even though the first person place is first, actually first position, but the shopkeeper may give the two products or one product for the second place, second position person, two products for the third position person, four products for the next position person, and so on. So here, if we observe, the shorter processes, less amount of the products who wants to purchase, they come and go from the shop, but still the person who wants to purchase 10 products, they're still waiting, still in the waiting state. So this is the meaning of this first point in the disadvantage. That process, that position is called starvation. Starvation is nothing but a process has to wait for the long period of the time when the remaining processes bus time is very less compared to that particular process. All the processes are shorter processes, but all the shorter processes are keep coming. That is why that particular process has to wait for a long period of the time. So this is called starvation. Sometimes you may get this question for this uh, for 3 or 4 marks, short answer questions. So what is starvation? Next disadvantage is it is not implementable because, as I said already, practically calculate the bus time is not accurate practically, but we have some theoretical concept. We are calculating by using some formulas, that is okay, but practically that may not possible. Now, see how to understand the shortest job first internally, the internal processes. So we have four processes, P1, P2, P3, P4. Bust time of those four processes, 6, 8, 7, 3 respectively, P1 6, P2 8, and so on. Now, our concept is shortest job first. Which process job have the least bust time? We need to find out first. Observe here, that is P4. Okay, P4. Because P4 bust time is very less compared to the all other processes bust time. First, we need to select P4, and for the P4, we need to give 3 seconds. Assume that one box is 1 second. Okay, 3 seconds of the time for the execution for the P4. Then completed execution is completed. Now, next 3. Among these 3, which have the less bus time? That is 6, P1. Okay, observe here this arrow mark, and the second P1 will be entered for the execution. 6 slots, 6 seconds in simple terms. Okay, then after that we have only 8, 7, obviously 7. Then 7 will be collected and sent for the execution. And finally, P2. Okay, because the bus time is 8, largest one among those 4 that will be selected. And finally, at the 24th seconds, this is cumulative values, the 4 processes execution will be completed. So if you have this question, you need to write like this. Okay, the Gantt chart and which process will be selected when and how many seconds are needed to complete the execution of 4 processes. Okay, this is about shortest job, and this is no need to you. This is master level. In the shortest job, again we have 2 categories, non-preemptive, preemptive, but as per your syllabus, you may not have this. Right. Next one is priority-based scheduling. The meaning is whenever the CPU is trying to execute multiple processes, a priority value, one numerical value, a number, is allotted to the processes that indicates the priority of that process. For example, you are working with your mobile, in that some tasks might be urgent. Let us say that banking application, you are trying to transfer the amount from your account to another account. That is priority based task that should not be delayed. Suppose you are sending one image to your friend. Sometimes that may get delayed. That is nothing problem in that. Like that, internally also, some priority processes are there. Those must be executed first. For that process, we have the one algorithm called priority based scheduling. Now, priority based scheduling is can be a preemptive and a non-preemptive, 2 versions again. In the priority also we have 2 versions, preemptive and a non-preemptive algorithm. Preemptive means episode wise in simple terms. Okay. Non-preemptive means complete movie, not a serial. At a time, the execution will be completed. And each process is assigned a priority because this is the priority based scheduling algorithm. Every process maintains a priority internally, and the process which has the highest priority that will be selected first for the execution purpose. First, FCFS, which arrived first, that will be selected for the execution. Second, we executed shortest job first. The rule is which process has the less burst time, that will be selected for the execution first. Now, third category is which process has highest priority, that will be selected for the execution first. Simple. Okay. Then how the priority will be decided, that is internal things. The operating system will take care about that, how the priority will be decided, because for that also so many factors are there, depending on the memory, depending on the time, depending on the nature of the task, that will be decided internally. But theoretically, while we are discussing the algorithms, we need to maintain some value to make the concept clear. See this, let me explain this with help of the simple terminology. Process, we have 5 processes, priority 1, 2, 1, 3, 1. Okay, this is somewhat complicated problem. You can take very simple problem to understand the concept. Then bus time 43742. Okay, this is the bus time of those 5. Then arrival time. So this is high level question, but generally, as per your level, you may not get this arrival time and bus time. Generally, you may get this priority column also because this is master level question. Based on this priority only, you can select the processes and create the Gantt chart. Okay. Observe here, suppose we have 5 processes and you may start the Gantt chart with P1 or P3 because priority is equal 1 1. Okay. After P3, you can go for the P1 or start with P1 or P3. Otherwise, we have one more rule also. Assume that P1 is came into the queue first, then P2, P3, P4. Whenever whenever two processes have the same priority, then you can go for the first come first serve order. The meaning is priority is same, but first P1 came into the memory. That's why you can start with P1. That is also one rule. Okay, P1, then P3. Next priority P3. Next priority P2, P5. Same priority. But P2 came into the memory first. Then go for the P2, then P5. After that, finally P4. Okay, so don't consider this. Okay, that becomes very lengthy calculation. So that's why process priority, because our main focus on the priority only. Based on that, you can take some values and create the Gantt chart, explain which process will be stored into the memory first and which will be executed first based on which rule. Okay, execute that. That is enough. Now, next very important scheduling is round robin scheduling. So this is generally primitive version, primitive type of the scheduling. Primitive means serial by serial, episode wise, part by part. Okay. Round robin is a preemptive process scheduling algorithm. Each process is provided a fixed time for the execution. The CPU time is fixed, even though the bus time might be greater than or less than that fixed time. But CPU gives some fixed amount of the time. Let me give a simple example. Let me continue the same hospital example. Assume that the doctor fixed his consultation time. The consultation time is 5 minutes. So here the thing is, suppose one patient entered into the consultation room. Assume that the person have multiple problems. They want to explain about their problems with the doctor. That 5 minutes is not enough. Assume that. But the doctor fixed that consultation time 5 minutes only. The rule of the doctor is he wants to talk or he wants to discuss with the patient only for the 5 minutes. That is fixed. But 5 minutes is over. But still, the explanation of the problem of that particular patient is not completed yet. Now, what happens is the patient must come out from the consultation room. The patient who is waiting in the queue, second position, they may enter into the consultation room and they spend 5 minutes. Assume that second patient may not have any problems, only a single problem, small problem. 1 minute is enough. But the time slot is fixed 5 minutes. Na? In such cases, that will be removed after the 1 minute. Okay. So the meaning is the CPU cannot provide more time than the fixed time. This is general terminology. But coming to the technical terminology, that time is called a particular quantum of the time. Each process is provided a fixed time to execute. It is called quantum. Once a process is executed for the given period of the time, it is preempted and other process executes for the given time period. Preempted means the patient has to come out from the doctor's room. Na? In the same way, that process must come out from the memory from the execution. More technically, that process state has to be changed from running to ready again. Already we covered na, different states. Running means that is being executing by the CPU at present. Ready means still again waiting. After completion of that 5 minutes of the time, that particular process must change the state from running to ready. Then again next process may enter for the execution. Like that for every seconds the processes must be changed in the cycle manner. So this is about round robin scheduling algorithm. Okay. Just like assume that you have three friends and you want to talk with all the friends. And one more assumption is they don't want to talk with each other, the three friends, but you only the friend for the all the three people. But among those three people, they are not friends. Assume that you went out for a particular place, totally four members, you plus three members. You are the friend for the all the three members, but three members are not friends. Now, what might be happening in the real time? You must talk with all the three members. That's why you must spend for 2 minutes to talk with friend one, next 2 minutes to talk with the next friend two, next 2 minutes to talk with friend three, again next 2 minutes from friend one, friend two, friend three, and so on. Because you only must talk with those because they are not friends, they don't want to talk. Assume that. So in the same way, execution process is also same thing in the round robin algorithm. P1, P2, P3, again P1, P2, P3, and so on. If the burst time is completed, the process must be come out from the memory. So this is the thing we need to follow about the round robin scheduling algorithm. Okay. Yes, you must remember these terminology and algorithms. Probably from this category only you will get the question. First come, first serve, shortest job first, priority based scheduling algorithms. Okay, and finally we covered round robin. Just try to understand the internals of the algorithms and understand that. Try to explain, and if time permits, and if you have the time, uh, try to read the explanation of the terminology what we are using in that algorithm. Like suppose round robin is a preemptive algorithm. Just now covered, but you must write what is preemptive also. So that is about CPU scheduling algorithm concept. Next important topic is deadlocks. No, let me come to the point directly because so many points are there, but the time is not enough if you want to cover each and every point. I'm trying to focus on the main important points. Now, deadlock. What is deadlock? A deadlock happens in the operating system when two or more processes, minimum two or more, two plus, two or more processes need some resource. Resource means any hardware resource or any software resource. Suppose printer, one process wants to use printer, one process wants to use scanner, or some one process wants to work with one document software. So everything is treated as resources. Now, two or more processes need some resource to complete their execution that is held by the other process. This situation is called a deadlock. Let me complete this with the help of the simple example. See now, this is process 1. Okay, process 1. And observe this arrow mark. This process 1 is already using resource 1. Okay, in other terms, resource 1 is already held by the process 1. For these arrow marks, there is a specific meaning. Resource to process arrow. The meaning is this resource is held by this process. Okay. Now, process to resource arrow mark meaning is this process is sending the request for the resource. Okay. Let me repeat again. We have the arrow mark here na resource to process. The meaning of this arrow mark is resource 1 is already held by the process 1. Okay. Resource to process meaning. Now, the edge arrow mark we have from process 1 to resource 2. The meaning is process 1 is sending the request for the resource 2 because the process 1 wants to use resource 2. That is why that process 1 is sending the request to the resource 2. Okay, that is the meaning of these edges. Now, if you observe the complete picture, resource 1 is already being used by the process 1. At the same time, process 1 is sending the request for the resource 2. Next, but already that resource 2 is used by the process 2. This is held by the process 2. And again, this process 2 sending the request for the resource 1. If this is happened, one resource is held by the one process and that process is waiting for the another resource, but that resource is also held by the another process. This case is called deadlock. Let me give a simple example. Suppose this is you and this is your friend. Okay, this is you and your friend, and you have one pen that is blue color pen. Okay, and your friend may have a red color pen, and you have given a task by the lecturer in your class. You need to write a letter and you must use blue and red color ink pens. Okay, but you have only blue pen, your friend have only red color pen. Now you started your work. Okay, process 1 is you, and already resource 1 is held by the process 1, nothing but already you are using blue color pen with you already, but you are waiting for the red color pen. Okay, because the rule is you must use two color pens, blue and red, two pens you must use, that is the rule. And your friend working with red color pen, red ink pen. Okay, that is resource 2. Already red ink pen is being used by your friend, but at the same time your friend is sending the request for the blue color pen, that is sending the request for the resource which is being used by you. But the thing is, you don't want to give the blue pen to your friend. In the same way, your friend don't want to give the red pen. You may think that whenever your friend gives the red color pen, you want to release blue color pen. You want to give the blue color pen. In the same way, your friend also thinking like that. Obviously, what will be happen? You won't give blue color pen to your friend, and your friend won't give the red color pen. Your work will not be completed. Your friend work also will not be completed. So all are will be stuck. Everything in the waiting state only. So this situation is called deadlock situation. Okay, nothing in the process. Process is waiting for the resources. Every process is waiting for another resource, but no any process is ready to release the resources. Okay, so this is deadlock. Now, how to confirm that there is a deadlock in the system? The operating system maintains some conditions to check whether the deadlock is occurred or not. Deadlock occurs if the four conditions, generally those four conditions are called Kaufman conditions. You may get the question sometimes like explain about Kaufman conditions. Remember, the properties or characteristics or conditions what we need to consider for the occurrences of the deadlock, those are called Kaufman conditions. Whenever these four Kaufman conditions hold true, but these conditions are not mutually exclusive. Okay. Now, the Kaufman conditions are, we will discuss those one by one. First one is mutual exclusion. What is the meaning of that? There should be a resource. There should be a resource that can only be held by one process at a time. The meaning is once a resource is being used or allocated by the one process, that same resource should not be allocated for the another process. This is the simple meaning of mutual exclusion. Okay, let me repeat. There should be a resource that can only be held by the one process at a time. One resource, one process, simple term. One resource, one process. This resource should not be allocated for the another process. That must be allocated whenever the work of the process one is completed with this resource. So this is mutual exclusion. Next, hold and wait. Next condition is hold and wait. A process can hold multiple resources and still request for the more resources from other processes which are holding them. Same thing. Already some resources are held by some process, but still again that process is sending the request for the another processes. See this diagram. We have process 2. Already 2 resources allocated for the process 2, but still this process 2 sending the request for the another resource, resource 1. If this is happened internally, this is one of the reasons to occur the deadlocks. Okay. Next, no preemption. Already we know what is preemption means. Once a process is allotted, even though the execution is not completed, the process must be came from running state to ready state. That is preemption. The rule is no preemption. If the no preemption is existed, there is a chance for the occurrences of the deadlock. Now, how to understand the no preemption word in this particular context? A resource cannot be preempted. A resource cannot be preempted from a process by force. The meaning is once we allot it, once we allocate any particular resource for the process, we should not take back. The operating system should not take that resource back. That resource should be released when the complete process is executed. That is mean no preemption. The resource should not be preempted, should not take back forcefully. Once we assign printer for a particular task, the printer should not be take back. The resource should not be cancelled. That is the meaning of no preemption. See in the diagram, process 2 cannot preempt resource 1. Process 2 cannot preempt resource 1 from the process 1. Resource 1 is already being used by the process 1. Resource 2 is allocated for the process 2. But still, process 2 is waiting for the resource 1, that is sending the request for the resource 1. Even though the process 2 is sending the request for the resource 1, the resource should not be released, should not be preempted from the process 1 because already that is allocated for the process 1. This is no preemption. And finally, the fourth one is circular wait. If in our system, if the OS observes circular wait, that may cause to occur the deadlocks. Same thing, just now we covered one diagram na circular wait. This is circular wait actually. Okay. See now, one process is sending the request for the resource 2, but already resource 1 is allocated to the process 1. One resource is allocated, but waiting for the another resource, sending the request for the another resource. And for which that is sending the resource, that is already being used by this process 2. Then process 2 again sending the request for the resource 1. This is circular wait. Okay. And finally, you must remember whenever these 4 conditions hold true, nothing but whenever all the conditions are true, all are occurred at a time, then only we can say that that condition is deadlock. Suppose assume that among these 4 conditions, only 3 conditions are true, one condition is false. We cannot say that is deadlock. Okay. So this is about deadlock characterization. If you have the question like what is deadlock and explain about the deadlock. Otherwise, explain about the deadlock conditions or explain about Kaufman conditions. Question, whatever it might be, the way of the asking of the question, concept is same. You must explain these four conditions in detailed manner to get good marks. Okay, this is circular weight. Same diagram again. Now we have different methods to handle the deadlines. In the tomorrow's session, we will discuss how to handle the deadlocks. As of now, we covered what is deadlock, how deadlock occurs, then how to solve this problem, how to handle this deadlock, what are the different methods we have to handle this deadlock. We cover those topics in tomorrow's session. Deadlock prevention and avoidance. These are also very important topics we'll cover in tomorrow's session. Okay. Yeah. Any doubts?
No, sir, no, sir.
Yeah. Right. Okay. Right. I will share this document also with you. Just go through it. Still, after reading this, if you have any doubt,
Okay, sir.
you can ask me in the tomorrow session also.
Okay.
Okay. I'm done. Right.